Okay, so first semester we finished off with so this whole year you are only talking about three main ideas. First one is limit. We finished that up within 2 weeks or so. The second big idea is derivative. We finished that first semester. The third big idea is this entire semester, which is integrals. So we're going to spend 3 chapters on integrals. And integrals are related to derivatives. That's why we're going to go back and forth on those two things. Okay, so Chapter 4.1, antiderivatives and indefinite integration. Okay, so let's kind of think backwards. If f prime of x, so if the derivative is 2, what is the original function? 2x. Okay, so you're kind of thinking, what would be the original one so that when I take the derivative, I would get 2, right? So 2x. Is 2x the only answer though? Probably not. Maybe 2x plus 1, right? If I take the derivative of 2x plus 1, I get 2 because derivative of 1 is just 0. Can I also have 2x plus 2? Yes. Yeah? So I can basically say that I just add anything I want here, right? When I take the derivative, that constant goes away. Yes? Okay, so the derivative is, the antiderivative or the integral is actually 2x plus c, saying that c is just some kind of constant because that constant goes away. So let's think about this in graphical interpretation. So let's think of this f prime equals 2 as in a slope of 2. Right, some kind of slope of 2. Slope of 2. So what is f of x? So let's say this is a slope of 2. It could be here with a line of slope of 2, or here, or here, or here. Any of those lines have a slope of 2. It's just where, it's translated up and down. Does that kind of make sense? Yeah? Okay, so let's define some words. Antiderivative is basically the integral. So anti means go backwards. So it's the derivative, but backwards. So from the derivative, go backwards. So antiderivative. And another way to say that is integral. And you might also see this word differential equation. Differential equation, DE for short. So differential equation is an equation in x, y, and derivative of y. So any kind of equation that has x, y, and the derivative of y means like y prime. Any equation that has x, y, and the derivative of y, we call that differential equation. So maybe an example will be y prime equals 3x. That would be a differential equation. Or maybe something like x squared equals y prime plus 1. That would be a differential equation as well. Okay, differential equation just means something with a derivative inside. Yes?
Isn't integral like the area under the curve?
Yeah, we'll talk about that. Okay, next, indefinite integral. Indefinite integral is the antiderivative of a function in general solution. Okay, indefinite integral means the antiderivative of a function in general solution. For example, okay, so when I say the integral, I'm going to write this. This means integral. Integral of 2x. So let's do 2 instead of 2x. Integral of 2 dx. So that means I want to figure out what was the previous function so that when I take the derivative, I get 2. Yes? Okay, so we already said that was 2x, right? Plus c, yes. So when we do indefinite integral, we have to have a plus c because it's the general solution. All the general solutions have plus c because it's trying to cover everything. Yes?
So like a normal integral would be 2x plus 1. Right?
Oh, okay. All right. We'll talk about that more today. But basically, we have two kinds of solution. One is called general solution. General solution goes with indefinite integral. You're always going to have a plus c. Instead of general, we will also have another kind of solution. It's called particular solution. That's going to be the one where c is defined. But we'll go into that later. Okay, now plus c. See, that has a name. It's called constant of integration. Constant of integration. And it only happens in indefinite integral because we are talking about a general solution. So constant of integration, yeah, let's just say the constant c. Okay, so now we are going to practice finding the integral. And there are some tricks, so I'm going to show you some tricks to find it quickly. Okay, so first question, find the antiderivative. So we are trying to find the antiderivative of 2x. I know how, once I teach it to you, you would do it really quickly. But part of doing the work is showing your work. So a lot of times you just write the answer, skipping the work. Please show your work. Okay, so I'm going to show you how to write the work clearly. Please make sure you write it every single time. We're trying to find the antiderivative of 2x, or we're trying to find the integral of 2x. So you're going to write an integral, 2x, and then we're trying to tell them which variable we're trying to integrate. So we're going to write dx. Okay, you got to write that every time. Integral, function, dx. Dx is very important. You got to write dx. Equals. All right, so think backwards. What function, when you take the derivative, you get 2x?
X squared.
Good, x squared. Plus c, yes. So I'm going to remind you on quizzes for now to write plus c, just in case you forget. Okay, plus c. All right, let's try this one. It's a little bit harder. Okay, so integral of 2x plus x squared dx. So integral of whatever that function is, dx. Now, this is a little bit ambiguous, so usually we put a parentheses around it to say that whole thing needs to be integrated. If you don't, it's okay because you put dx at the very end, but let's say you forgot. You might be confused. Am I integrating this or am I integrating the whole thing? So just put a parentheses. All right, so the rule about integration is if they're added together as if it were a polynomial, you could split it into each integral. That way you can integrate it quickly. All right, what is the integral of 2x? Okay, x squared. This one's a little bit harder. Integral of x squared.
1/3.
Oh, you guys are very fast. All right, so here's how you do it. When you integrate, you're always going to be 1 power higher, right? Right? Yes? Because that's how you're going to get to x squared. So let's make a guess. X cubed. Then take the derivative. 3x squared. I don't want that 3, right? Because I'm trying to match it with x squared. So what you're going to do is you're going to put a box here, and you're going to ask yourself, how do I get rid of this extra constant that I don't want? 1/3, right? So then you put 1/3 here, and you put a 1/3 here, so the answer is 1/3 x cubed. But like I said, eventually you're going to be really quick. You're going to do this in your head. Okay, so plus 1/3 x cubed plus c. Good? Okay. All right, next one. Integral e to the x plus 3x dx. Okay, you don't have to split the integral every time. I'm just telling you it's okay to split. You can just integrate like that. You don't have to make it into two integrals. Okay, what is the integral of e to the x? Good, e to the x. What is the integral of 3x? If you're not sure, try my trick. Okay, so what is the integral of x as in x squared? Okay, so x squared. All right, take the derivative, 2x. I don't want that 2. I don't want that 2, but I want a 3. 3 halves. 3 halves x squared plus c. Good? Okay, once you practice more, it gets easier. Number 4, go ahead and try this one. Okay, what's the answer? Yes, plus c. All right. Now we're going to look at special derivatives where it's not just power rule. It's you have to remember that derivative. What is the integral of sine x? Negative cosine. So it has to be a cosine to get a sine, but when you take the derivative of cosine, you get a negative sign. We don't want that negative. So negative cosine, x plus c. So these you just have to kind of memorize. Okay, number 2, integral of 1 over x. Yes, natural log. Yes, question.
Is that like a little integral symbol? I don't even know.
Yeah, this is called the integral symbol. Yes.
Yeah. Is it like supposed to be an F? Like I don't know. Look at the F right there. It's very
I don't know. I don't know the history of integral sign. Okay, so integral of 1 over x is natural log. Okay, plus c. Plus c. And we only want positive numbers inside the natural log because negative numbers is not going to work. So we got to make sure you put a absolute value around it. Okay, next. This one's a little harder. Let's make an educated guess. What do you think the integral would include? It will include log, yes, somewhere, but what would be a good guess for b to the x?
X could be.
What would be a good guess of the integral of b to the x?
dx plus 1.
Oh, log x.
Oh,
Log x
no.
should be.
Okay. Would definitely be b to the x, right?
Oh, yeah.
Because the derivative of b to the x is at least just b to the x. Yeah.
That makes sense.
Blank looks. Okay, we forgot our derivative rules. Okay, take the derivative. The derivative of b to the x is
X times
b to the x.
minus 1.
No. You don't do power rule when the exponent is not a constant.
And then
Log b.
is it?
Yeah. Okay, b to the x log b. If you don't remember, review last semester. Okay, so the derivative of b to the x is b to the x times log b, but we, not log b. Hold on. Natural log b. Okay, well, we don't want this natural log b, right? So what do we have to multiply by? Okay, 1 over natural log b. So the derivative is going to be 1 over natural log b, b to the x plus c. So this is just a matter of whether you remember the derivative of b to the x or not.
These we can just memorize, yeah? You said?
Yeah, you can just memorize this now, from now on, sorry. All right, number 4, integral of cosine. Sine x plus c, very good. Okay, the next two. You might really have to look at your notes because I think maybe a hand of, the previous one? Okay. Oh, yeah, right. There you go.
There's sine inverse. Inverse sine.
Inverse sine, that is correct.
Yay.
So this will forgot an X there. This will definitely be on the AP test. So you gotta remember inverse sine, you gotta remember inverse tangent. Those are the only two you need to remember. This is inverse sine. Plus C. You're gonna be my designated plus C person now. Please, yes, remind me every time. Okay, good. Everyone's copying. Huh? This one? I just explained it.
There's no plus C
Here.
Yeah.
Oh, that's the answer?
Yeah.
Yes.
What's the derivative of that? Speed.
All right, last one. It's just, huh? Yes, arctangent.
Plus C.
Plus C, very good. So inverse tangent plus C. Okay, so again, these are just whether you memorized it or not. If you didn't, it's just impossible to find the answer. Yeah. Okay, so I'm going to give you some tips on finding the antiderivative. Number 1, you should always change radicals into fractional exponent. Because you want to utilize power rule. So if you have a radical form, it's very hard to see what you need to do. So definitely change everything to fractional exponent. Next, split up one fraction into smaller fraction if it's going to simplify the process. You don't have to write this down. You just have to understand the idea. So for example, if you have an x squared plus 1 over x, that seems impossible to integrate. So what you want to do is split it into 2 fractions. So x squared over x plus 1 over x, or x plus 1 over x. Now it's easy to integrate. So if you have a fraction that has some kind of polynomial on top, you should split it. The last one is, please just remember, if it's asking for general solution, don't forget plus C. This is very important because this is where your points are going to come off for very minor thing, just forgetting that plus C. Okay, let's try this one. Find all function is a key for plus C, G, so that G prime is this. So if we want to get to G from G prime, we need to integrate. Right? You're going backwards. So the integral of, let me write this whole thing out very clearly. So G of x is equal to the integral of G prime of x dx. And G prime of x is 4 sine x plus 2x to the 5th minus square root x over x dx. That sounds crazy. But it's actually not too hard. So utilize some of the rules or tricks I told you. Yes?
What was the point of putting g of x equals the derivative?
That is just to make the problem very clear. So kind of, you got to do this when you're doing FRQ. You're showing them how you're going to get your answer. you're telling them that you understand g of x is going to come from the antiderivative of g prime.
Wait, so we have to write that?
Eventually, yes. Yeah. Just to make it very, very, very clear that you know what you're doing. Okay, so now we're just going to integrate, and this part looks crazy. So how do we simplify that part? Split it up. Very good. So what would it become once we split it? 2x to the fourth, okay, and then?
Minus x to the 1/2 over x.
Yes, so we have a minus square root x over x. So that's the same thing as minus x to the 1/2 over x, right? And so that tells me I'm going to take the power on the top minus the power on the bottom. So 1/2 minus 1. Negative 1/2. Yes. Okay, now integrate. What is the integral of 4 sine x? Yes, negative 4 cosine x plus the integral of 2x to the fourth. 2 over 5x to the fifth. This one, I always have a problem with the fraction, so I try not to do it in my head. I just write it out. So what's 1 degree higher than negative 1/2? 1/2. So my guess is 1/2. I'm going to integrate. 1/2 x to the negative 1/2. All right. I don't want the 1/2. I want the negative. Negative 2.